Hello scholars, this video will help you to study for the Module 1 Topic C Exit Ticket Test. When studying for the test, you could take the attitude of this young man. While clever, he is kind of showing an attitude of avoidance, which may not result in achieving a goal. We could think of the words of another very clever person and take the attitude that leaders are made, they are not born. They're made by hard effort, which is the price all of us must pay to achieve any goal that is worthwhile. So if you're viewing this video right now, you're making the effort that will help you to achieve the goal of the Topic C Exit Ticket Test. Ratios of fractions. Question 1. If 3/4 pound of tuna sells for $12.60, how much would 1 pound of tuna cost? What is one challenge we see in this problem? The challenge is that one of our quantities, pounds of tuna, is expressed as a fraction, while the other quantity, its price, is expressed as a decimal. So our choices moving forward would be choice 1, express both quantities as decimals, or choice 2, express both quantities of fractions. Which choice would you make, thinking about which form of the numbers would be easier to compute with? If we go with choice 1, we would need to express 3/4 as a decimal. What is 3/4 as a decimal? So here we can see that 3/4 is equivalent to 75 hundredths. So if we divide 4 into 3, we'd get 75 hundredths. So we can say 75 hundredths pound for $12.60. But what if we chose choice 2 and expressed both quantities as fractions? What would be the equivalent fraction to $12.60? Here we can see that 12 and 6/10, that 6 would be the numerator of our fraction. Its place value, tenths, would be the denominator. So we could say that 12 and 6/10 is equivalent to 12 and 6/10, which is equivalent to 12 and 3/5 if we simplified it. We could express it as a fraction as 63/5. So really, if we choose choice 2, we're going to have 3/4 pound for any of these representations. The number of dollars could be any of these fractions. So if you consider these are the numbers you're going to be computing with, or these are the numbers, which choice would you make moving forward? Choice 1 or choice 2? We can continue to show both choices, but I would really only focus on the one that you think is most useful, and you're not required to do them both. Looking at the numbers, I'm voting for choice 1. I feel that the decimal representation would be easier to use, so we're going to move forward with choice 2. Moving forward with choice 2, we could form a rate to compare our two quantities. But which rate should we choose? 0.75 pounds for every $12.60, or the price per pound, $12.60 for every 3/4 pound? So which rate would you choose to help move you forward to the answer? If we go back to the question and see what our goal is, we realize we want to find the price for 1 pound. And so we want to calculate a unit rate for each 1 pound. How much does it cost? And so our second choice, $12 price per pound, would lead us to that unit rate. And that's usually how things are priced. The price we would pay for each pound, not the pounds that we could get for $1. So how will we go from our rate $12.60 per 75 hundredths pound to the price for 1 pound? What can we do to get from where we're at to our goal? So to calculate our unit rate, we would divide the numerator divided by the denominator. But since there's a decimal in our divisor, we're going to need to solve an equivalent division problem. What equivalent division problem will we solve? Since there is a decimal in our divisor, we're going to move it 2 places to the right to divide by 75, and we'll balance that here. We'll move our decimal 2 places right in our dividend, and so we're going to divide 75 into 1,260. What does that equal? So here's our answer to our division, 75 into 1,260, or 75 hundredths divided into 12 6/10. So we would then have our unit rate as $16.80 per pound. Just to note that on the fraction option side, if we had organized a rate in the same order and had 63 fifths dollars divided by 3/4 pound, we could still get to that same correct unit rate. We just need to decide which option seems most useful, the decimal representation or the fraction representation. Question 2. Which store offers a better buy for the same sliced roast beef? Show your work and explain your reasoning. So in question 1, we showed the skill of comparing 2 quantities in a rate and finding the unit rate. If we apply that, unit rates can help us to compare store A to B. So here's our goal, to have the unit rate for store A, the price per 1 pound, and the unit rate for store B, the price per 1 pound. And we want to think, what would be the better buy? Is the better buy the rate with the smaller or bigger numerator? So here are the choices we need to make, and whether and how to move toward that unit rate, price per 1 pound. We could say 3 75 hundredths pounds for $10.50, or 3 3/4 pounds for $10.50. You have to decide which one seems more useful to you. So we look at these 2 options side by side. We have a rate, price per pounds, and we can look at what math is involved to get to our unit rate on each side, and again, be thinking about what's most useful to you and focus on that form of the 2 numbers. So if we follow the process for using our decimal forms to our unit rate, here's our rate, here's our division problem, and it arrives at $2.80 for 1 pound. We could make a complex fraction, 21 halves divided by 15 fourths, and that would take us here, and we'd get 2 4/5 per pound. 2 4/5, 2 8/10 are equivalent. So now we would want to find the unit rate for store B and compare it to store A. So on this side, we have our rate, $6.25 for 2.5 pounds. I think I would go with the decimal form. It definitely seems easier than navigating the fraction form. But you can choose your path, but let's find the unit rate for store B. What would be the price for 1 pound at store B. So by dividing our numerator by our denominator, we get 2.5. So at store B, we have a unit rate of $2.50 for 1 pound. So which of these represents a better buy? So store B offers the better buy because it has a lower unit rate. Question 3. A tablet computer is put on sale 1/4 of the original price. If the tablet originally cost $180, what is the sale price? So in class we use models, the tape diagram and or the equation to help us solve these types of problems. So to do a tape diagram, I have my don't pay and do pay colors, and I've divided my rectangle into 4 pieces equal to the denominator. So how many squares should I color don't pay? The language of this problem can be tricky. I say, so we need to connect the sale to 1/4, and so that means we would take don't pay 1/4. And that means that we do pay 3/4 of the price. So what equation, if you want to challenge yourself to model this with an equation, what equation fits with our tape diagram? So here's the equation. Y equals 3/4 x represents this tape diagram, or an item put on sale 1/4 of the original price. So the next question we need to ask ourselves is, what do we know about what quantity do we know? Do we know the sale price, or do we know the original price? So what number is in the problem and where does it go? So we know that the sale price has a question mark by it. So we don't know what that is yet. So that will be a question mark. But we do know that the original price was $180. So $180 goes here. In our equation, that means it would be substituted for x. So to move forward, we need to find the value of 1 box in our tape diagram. So to do that, we're going to divide. But what will we divide by? So we divide by 4, because 180 is being shared by 4 boxes. And now what we know is what each box is worth. Each box is worth 45. So how would we find the sale price? So the sale price is what we do pay. It's the number of boxes in our do pay color. So we could find that by 45 times 3, which equals 135. So if you wish to use the equation, after substituting 180 for x, we would multiply 3/4 times 180. That could give us 540 divided by 4. That also is $135. We can get to the correct sale price using either model. You don't have to do both, but you want to choose one good method to find an accurate answer. Question 4. A bike shop marks down a mountain bike 1/5 of the original price. If the discounted price of the mountain bike is $840, what was the original price? So we have our tape diagram set up, and another option would be thinking of our equation. So if we're thinking about our don't pay color, how many total squares should there be, and how many should be colored don't pay? So what do we know about this mountain bike? Do we know its sale price, or do we know its original price? So we know its sale price. We know that it's on sale for $840. What we don't know is what we would have paid for it before the sale. We don't know its original price. One way to help us find that out would be to figure out what is the value of each square in our tape diagram. To find the value of one square, we divide 840 by 4, and that would tell us that each of these is worth 210. And we'll fill that in. So how can we find the original price? So we could find the original cost by multiplying 210 times 5, or adding up all of our boxes. And so that would be an original cost of 1,050. If we substitute 840 for y, we can see that 840 is equal to 4/5 x. And x would be equal to 840 divided by 4/5. That would also mean that x is equal to 1,050. Question 5, the challenge zone. To make green paint, students mixed yellow paint with blue paint. The table shows how many yellow and blue drops the students used. Yellow drops Y, 3 1/2. Blue drops B, 5 1/4. A student used 6 3/4 drops of blue paint. How much yellow paint should she use to make the same shade of green as shown in the table? So I'll go ahead and give you the answer to the challenge zone. She should use 4 1/2 drops of yellow paint. There would be a lot of different ways to arrive at this correct amount of yellow paint. If you have a way that you understand to get to 4 1/2, you're ready for a advanced grade on this test. But if you have questions on why the answer is 4 1/2, let me know, and I'd be happy to work on the challenge zone with you.